Hello and welcome to your first lecture on signals and systems. Signals and systems. So what is a system? A system is a meaningful interconnection of devices and components in order to achieve a certain goal. So this black box here can be assumed to be a system. A system takes one or more inputs, which are called signals. It acts on these signals and produces one or more output signals, which are in some way more desirable than the input signal. The input signal usually is a dependent variable, which means that its value varies as a function of one or more variables. Let's say if the input is a function f depending on x, then the output would be y depending on x, or depending on multiple variables x1 till xn, and y of x is in some way more desirable than f of x. Now let's look at some examples of systems in electrical engineering. For example, an RC circuit which has its input Vi of t and produces an output across the capacitor V0 of t. This is a resistance and this is a capacitor. This can be assumed to be a system. So we provide it an input Vi of t and we take this output V0 of t. Let's say if Vi of t is a unit step function like this, that is, it is 0 up to a certain time, let's say 0, and then at 0 it changes its value from 0 to 1, and if this is the input Vi of t, then the output is a ramp function like this. This value here is 1. So this system is nothing but an integrator. So we give it an input Vi of t and we get this output V0 of t. So this is an example of a system. An induction machine is also an example of a system. We provide it with electrical power at the input. Let's say a three-phase induction motor is provided by a three-phase power supply, and it produces mechanical output P out and torque at the output. So this is an example of a system which converts electrical energy into mechanical energy, which is then used to drive a shaft of a generator in order to produce electrical power. So in this course on signal and system, we would be looking at some of the fundamental tools for analyzing complex systems, such as the Fourier transform, the Laplace transform, the Z transform, these tools really form the backbone for more complex engineering courses such as control engineering, control engineering, circuit theory, DSP, and many others. On my channel, I also have lectures on these other courses, so if you are interested, take a look at them. In this lecture, I just wanted to give a brief introduction to the scope of this new lecture series on signal and systems, which I am going to start. In the next lecture, we would look at some common types of signals that we encounter in electrical engineering. So see you in the next lecture, and thank you for your attention. Bye.